All right, so let's talk about it. What was the question? It was, all right, so we had the, I'm going to write the whole thing out here. So, house, cabin, blah, blah, blah. So we have, ABCD. So we have, this is the quiz here. So we had the A, and that was 180. And then the B was 200. And the C was 190, and the D was 185. A, B, C, D, and then that was house, cabin was down below, and then the boat. And this was 60, 50, 40, and 55. Whoops, come on. 40, 55, 16, 12, 18, 10, okay. And then down below that, so remember how we're supposed to do, they're asking about initial allocation of player B, blah, blah, blah. So how do you, first off, if you look back at the ones the other ones you got to find out what's fair, right? For each of them. How do you find what's fair for anybody? Add them up and divide by how many people? Yeah, 3 people. Oh, no, 4. 4 people. Yeah, it's always the number of people, not the number of objects. Yeah, right, because fair is fair among the people, right? So if there's 4 people, they should each get 1/4 of whatever it is the pot you're dividing up, right? Does that make sense? So there's 4 people, so we got to add it. Now, we're just talking about B, so I'm just going to add up B. Was it 262,000 divided by 4? See, I just added that up. And then divide by 4, I'm getting 65,500. That's a fair share for B. Does that make sense? So notice if the 262,000, that's the total value of everything, the house, the cabin, and the boat, to B. That's what B thinks it's all worth, right? And B knows he's one of 4 people getting this stuff, so he thinks he should get 1/4 of the total value. So total value divided by 4, he thinks he should get 65,500. Now, what's their question? Their question is, in the initial allocation, so what will B actually get? Well, let's go through the objects. Who's going to get the house, actually? Yeah, B will get the house. He's the highest bidder on the house, huh? Who will get the cabin? Looks like A, right? A is the highest bidder in the cabin. Who's going to get the boat? C. Yeah, C. C gets the boat. All right. So what's going to happen with B? So B will get the house, first off. B gets the house. Now, what is it? What is that? Oh, C is the only one where it said get the house. I see. So that was nice, wasn't it? You didn't have to have all the numbers perfect. That was not a hard quiz question. Some of the other ones will be more tricky when they ask you about the numbers. But yeah, that's the only one that said C gets the house. And you knew B gets the house. So B gets the house. Yeah, certainly B gets the house. And then how much money? How do you know how much money B gets? So what do you got to do? So how much is B thinks the house is worth 200,000? He said it right here, right? He could have written anything he wanted there. On his bid, he said, I think the house is worth 200. We said, okay, B, you get the house. So in B's mind, B thinks he was handed $200,000. And what does B think is a fair share for B? Only 65.5. So B, to be fair, was just handed way more than he thinks is fair. He was handed $200,000 value. And he should have only been handed fairly 65,500. So he's got to pay back the difference, to be fair, right? He's got to pay back whatever that difference is. So 200 take away 65.5 would be, is it 1, 3, 4, 5? He's got to pay back 134.5. And he gets the house. That's the initial. That's what they called the initial allocation. That's the words they said. Remember, later on, there's a surplus, and you divide that up among the people as well. But that's down the road. They just asked about the initial allocation on the question. So that would be this, we're done. Just the first phase where you give them what's fair and no more. The surplus comes later. Is that good? You guys okay with that? We'll take a practice test on this stuff tomorrow, and then the real test is... It's not when it's the day after that, Thursday. So put that on the board. Where's my pen? There it is. Yeah, so the real So well, let me just write it on the thing too. So our plan is practice exam number 2 tomorrow, Wednesday, and the real exam number 2. And exam number 2 is chapters 3 and 4 will be Thursday this week. You guys all have I gave you the new syllabus last time, or the new schedule, right? You all know when the tests are and practice tests and all that. So yeah, so that's the plan. So you will be tested on this stuff. Practice tomorrow, real thing Thursday. Questions on that one then? Good on all that? Making sense? We'll review this more when we go over the practice exam tomorrow. Okay, well, let's keep moving. Oh, let me tell you about the test. You guys got a test back. Okay, so there's that. I just made the table big, and then I'll answer all the questions. So there's the table. They cut up some kind of cake or something using the lone divider method. I don't think all the numbers matter, or maybe they do. What did? Sorry, our clarity. So they said pizza is worth $24. So the pizza's worth $24. So what? What does that mean I do right away? Do you realize I can figure out this box? How can I figure out that W box at the top? Because all of Abe's numbers across Abe have to add up to 24. They all have to add up to total 24. Make sense? Because Abe is saying how valuable he thinks the pizza is. So we have some big pizza. We cut it into well, that's 5 slices, huh? No, that's 4. Yeah, we cut it into 4 slices. X, Y, Z, W, and there's different whatever toppings on the different parts, okay? The whole pizza's $24. Abe thinks piece X is worth $5.75. That's what that's saying. Abe thinks piece Y is worth $6. Abe thinks piece Z is also worth $6. So what does Abe think piece W is? Well, whatever the difference from $24 is. Does that make sense? Because they told us the whole pizza was worth $24. So you just add up Abe. So for Abe, 24 minus whatever 575, 6 and 6 makes, huh? 24 minus 12 minus 1775. So what is that? 625? Did you do that right? I think it's 625. Did I mess up? 625, right? Yeah, 625. So that means over here, this must be 625. That must be how much Abe thinks piece W is worth. You guys tracking with me? So we got a total for Abe there. So now we can do the same thing for Corey and Dana. We'll come back to Betty. Corey and Dana. Corey, Dana, same thing. Just add them up, subtract from 24, right? Because the pizza's worth $24. They're each saying how much they think each piece is worth. So for Corey, let's do the same thing over here. For Corey, it's 24 minus 575, 625, and 625. So it's 24 minus 1825. So it's what? 575 for Corey over there. And then for Dana, same thing. Dana must be $24 for the whole pizza, minus 575, 575, $7. So 10, 1150, 1850. What's that? 550. Is all my math right? Those numbers good? 550. So, does that make sense so far? Now, how are we going to do Betty? We've only got one number for Betty. Total's 24, but how are we going to do it? You know, Corey, you know?
Split it up. It's coal.
Oh, Cole. And Chad. It's always some kind of C name. Sorry, Chad. So, do you know?
Coal.
Cole. I'm not good with names. Have you noticed? All right, Cole.
Couldn't you just minus 24 minus 6 and then spread it equally?
Well, how do you know it's spread equally?
Because it adds the 24.
Yeah, but couldn't it be, so that, why couldn't it be bigger on some and lower on others? Why's it got to be equal?
Because the chances are.
Why?
I have no idea.
Cole, yeah, I thought you were going to be there. You almost had it. Why are they got to be equal?
Because there has to be a divider.
There has to be a divider. She's got to be the divider. Remember, somebody does the cutting. And what does the divider think? They're all equal. The divider will cut. There is somebody who does the cutting. Try this. If you ever have kids, throw the cookie out there. You'll see. They're like suddenly a surgeon. They are so careful. It's amazing. Right? They will cut it to where they think it's fair because they know they get last pick. They will. So, has anybody else? Now, they didn't tell us Betty was the divider. They never said it in the words. I mean, I know you can't see all the words right now. But I'll tell you this much. In the question, it doesn't tell you who the divider is. Well, then how do I know it's Betty?
Because everybody else has a different amount of prices.
Nobody else has equal all the way. Somebody has to have equal all the way. Somebody has to, because they're the divider. Since nobody else does, it's got to be Betty. So Betty is 6 all the way. 4 times 6 is 24. Sorry, just cracked me up. Right, right, Cole? All right. I don't know how many times I can get your name wrong. We'll see. We'll keep a tally. All right. So 625. Yeah. So and then 6 all the way for Betty. All right. So then the first question they're going to ask you, who's the divider? That's the first question. Betty. Obviously, we now know Betty's the divider. Next question, they're going to say, all right, what's a fair share? Then they're going to go down the list. Right. So what would Abe say? What would Abe say is a fair share? If you asked Abe, hey Abe, which of the 4 pieces of pizza, right, remember this is a big pizza. This is some big pizza. They cut it into 4 pieces, X, Y, Z, W, that have different toppings and stuff. Which of the 4 pieces of pizza would Abe say is fair? What's fair for Abe? Would he like piece X? Would he like Y? Would he like Z? Would he like W? How do you know? What's fair? Remember how we always determine fair? Total divided by number of people. Right? Remember, fair is always getting, you know what it means? If somebody said, hey, there was $24, there were 4 of us, I got a fair share. You know what that means? 24 divided by 4. Right? Is that what we're talking about? So fair is 24 divided by 4, which is $6. That's 1/4 of 24. So anybody that gets a piece of pizza that they believe is worth $6 or more, they're going to think they got fair. So for Abe, which pieces are fair for Abe? Yeah, the ones that are so Y, Z, and W, not X, is fair for Abe. Y, Z, and W. What is fair for Betty? What's fair for Betty?
Whatever.
All 4. Right? Because she's the divider. She cut them that way on purpose. They're all fair for Betty. What's fair for Corey? Yeah, Y and Z only, huh? Those are the only ones that Corey thinks are worth $6 or more. That are fair. Good. What was this? Was this 550? I think so, right? 10. And finally, what's fair for Dana?
Z.
Only Z. That's the only one Dana thinks is fair. He thinks all the rest are less than fair. They're less than $6. Does that good? That's what they're going to ask you for in the rest of the question. So you see how we came up with that? So then the final thing is they're going to say, hey, is there a way to do this fairly? Is there a way that everybody can get a piece of the pizza and feel like they got a fair share?
In the question, I'm confused on how they're asking you. Can you explain it?
What does it say?
It says the term each chooses bid, list the choosers in alphabetical order. Let chooser 1 be C1, let the second label be C2, C3,
Yeah.
C4. I don't know how to do this.
So who is it who did that? Yeah. Determine the chooser. So C1 is Abe.
Right.
And they just want you to put in Abe, Y, comma, Z, comma, W. Exactly what I got. I think so. Let's try to see if I'll take that. Y, comma, Z, comma, W. Oh, yours is different. Yeah, so I think I just want you to list the letters. Yeah, good. That's what they want. Yeah, so they want just the answers I have up there.
Okay.
Yeah, it's just like that. The fair for Abe, fair for Betty, fair for Corey, fair for Dana. Yeah, so final question they're going to ask is there a way then to give each of the 4 one of the pieces of pizza and they will think they've been treated fairly? Is there a way for everybody to feel good about the situation? That's what it means to be a fair division. Is there? You know where you need to start? If there's going to be a fair division, if there's going to be like a fair way of doing this thing, fair division, then you have to start with whoever's most picky. Who's most picky? Dana. Dana only wants the Z. That's all Dana will feel good about. So you say, all right, Dana, you get the Z. So far, so good. Dana's happy. Next, you come to whoever's next most picky. Corey. Corey is only going to feel good about Y or Z. We've already given Z to Dana. So what do we give to Corey? The Y. You with me? Now, we've given out Y and Z. Now, Betty can take anything. We'll say Betty for last. Let's go back to Abe. Abe will be happy with Y, Z, or W. We've already given out Y and Z. Abe gets W. And now, Betty can be happy with anything. What's left? Just X. We give Betty X and everybody's happy. So there is a way to be fair. In this situation, there is a way for everybody to get a piece that they think is a fair share. And they have different values, obviously, different value system. But there's still a way to make it fair. There isn't always, but there is on this one. Is that good? Pretty good with those? I move on from that. All right, so let me give you a second. See what you can do. The main thing you have to figure out right away is what a fair share is. What's a fair share in this one? How do you figure out what a fair share is? It's this right here. $2 million property value. $2 million property value. So you got to take the 2 million, right? 2 million, and you got to divide it among how many people? 4? Yeah, 4. So fair. So the first thing is to find out what fair is. Fair will equal, and that's going to come out 500,000, right? Fair is going to be 500,000. See how I took the total. Just like last time, the pizza was worth whatever, was it $24 divided by 4. This time the total property is worth $2 million divided by 4, $500,000 each. So now you go in and you circle all the bids that are $500,000 or more, because they're all fair in their eyes, because they're all equal to a fair share, right? Just like in the last problem, we circled all the bids that were $6 or more, because that was fair. So I underline that, and that, and that, and that's it. Those are the ones that are fair. Those are the ones that are 500,000 or more. Are we good? Who's the divider? Burley, because they're all equal, huh? Burley's the divider. So anyway, now, is there a way to make this thing fair? Let's go over here. So if you're going to make a fair division of this thing, so this one's easier because I didn't have to subtract, and fill in any of the missing numbers. If you're going to do a fair division of this thing, start with the most picky, right? Who's the most picky person that really only wants like one particular thing? Greedy. Goes by the name. Greedy. Greedy is only going to be happy with section 1, right? That's the only one Greedy thinks is fair. Doesn't think the other ones are fair. So we got to give Greedy section 1. Got to give Greedy section 1. So after we've given Greedy section 1, who's the next most picky? See how Dandy only has 2? So Dandy would be the next most picky. So I'm going to go to Dandy. And Dandy is happy with section 1 or 2. See how I'm doing that, guys and gals? Is that making sense? Dandy will take section 1 or 2. Which one do we give to Dandy? We've already given out section 1. We gave it to Greedy. So, got to be section 2. Is that good? Now, Burley's going to be last because Burley's the divider and will be happy with any of them. So the one right before the last, second to last, will have to be Curly. Curly will take S1, S2, or S3. We've already given away S1 and S2, so give Curly S3. Right? Because Curly has got underlined S1, S2, or S3, right? So give Curly S3, and Burley will take any of them. What's left? S4. There you go, Burley. All right, so there's the answers to the question. That is a fair division. Everybody will feel like they got a fair share. Even Mr. Greedy. Good on that. All is well. All right, I'm going to. Okay, so there we go. We have 13 objects up there. So this is the last kind. We've got different ways of doing fair division, right? We've done the sealed bids for the lawyer, breaking up the inheritance. We've done the cutting up a cake or land or something like that. Last thing is, what if you have like a whole bunch of objects and you want to divide them up fairly among a bunch of people? Here we have 13 items. One way you could do it is called the method of markers. That's this last way. These are just different ways to make things fair. Method of markers. And you have every player in the game. Like if you have a bunch of kids, right? Halloween's over. Kids are there. You got all the candy. You just lay out the candy, the extra candy, and say, all right, kids, here's the extra candy. We're going to break it up, right? And not just everybody grab everything. This would actually be pretty complex for kids, I think. Well, I don't know. It's the end of the world. But anyway, put markers down where you think things are fair. So in other words, let's look at them one at a time. Look at A, for example. This is only three kids, 3 players, A, B, and C. Look at what A has done. A put a marker right here, A1, and A put a marker right here, A2. See the A1 and the A2? Don't worry about the B's and the C's. We'll come back to those in a minute. Just focus on A with me for a minute. Let me tell you what that means. When A puts markers in those 2 places, what A is saying is, I think that those are 3 fair shares. A can put them wherever he or she wants them. A is saying candies 1, 2, and 3 are great. I would like them. Or 4, 5, 6, 7, 8, 9, and 10. Those must be less valuable in A's eyes. And then 11, 12, 13. A thinks those 3 sections of candies are pretty much equal in value. A would be happy with any of the 3. That's why he put the markers there. We're saying A, break it up into 3 equal sections, however you want. So A puts his 2 markers down, and he breaks up the candy in his eyes into what he thinks are 3 equal value sections. He must not like the candy in the middle as much, because it requires more of it to be equal value to him. Does that make sense? And then B did the same thing, but B values things differently. Maybe B likes chocolate and A doesn't, or whatever. So B put a marker here. Whoops, kind of scribbling over the B there. B put a marker here and here. There's where B put his first and second markers, right? So B thinks that's 3 equal sections of candy. 1 through 6. And then 7, 8, 9, 10, and 11 through 13. 11, 12, 13. That's how B feels. B thinks those are equal. Making sense? See what they're doing? They're each putting their markers down. 2 markers break the thing into 3 sections. Like if I took the stick. If I cut the stick in 2 places, it would be in 3 pieces then, right? That's what they're doing. They're taking the string of candy, they're putting 2 markers down, which breaks it into 3 sections, right? And they think those sections are 3 equal value sections. And then C is putting the marker down here and here. So C thinks those are 3 equal value sections. All right. So what does that all say then? That says, now how are we going to do this fair? How are we going to divide this up fairly? Well, the basic input, let me go back into all right, so the way this works is the method of, I'm going to write out some steps here. The method of markers is number 1. You take first number 1 marker on the left. Take the first number 1 marker on the left. What do I mean the number 1 marker? Well, see how A has a A1 and A also has an A2 and B has a B1 and a B2 and a C1 and a C2. See how there's their first marker, their second marker? So I'm saying take the first marker. So what's the first marker on the left? Well, this A1 right here. Oops, it's A1 right here. And give the candy left. So 1, 2, and 3. A gets candy. 1, 2, and 3. Number 2. Good so far. You just go to the very first marker and you said, A, you put a marker first. You said you thought 1, 2, 3 was a fair share, or you wouldn't have put your marker there. So A, you get 1, 2, 3. There you go. A gets 1, 2, 3. A's going to feel good, right? It's a fair share. A put their marker there. They thought that was a fair share. So they get their marker. Next, take the first number 2 marker on the left. So what's the first number 2 marker? C2. Right? Because A2 and B2 are further to the right. So I'm not doing the C1, B1. Those are first markers. I'm taking the first number 2 marker. Right? Everybody with me? So you take the first number 1 marker, you take the first number 2 marker. So I'm taking the first number 2 marker right here. Now, and I'm going to go left. Go left to that. Go left. Let me say it this way. Go left, but here's the mistake everybody makes. But only give that letter their section of candy or whatever it is we're breaking up here. What am I talking about? I'm saying only go between the 2 C markers. Don't give candy 4 to anybody yet. Give 5, 6, 7, 8 to C. This is A's section. This will be C. Why? Because C said so. See C's 2 markers there? C put markers between candies 5 and 8, saying, I think candies 5 to 8 are a fair share. Don't give him more than his fair share right now. Right? We always just give fair at first and then the extra. That's for the adult. No, I don't. But we'll have a few extras in a minute. So that makes sense. There's the play. I'm camping on this one because when I've tested, I don't know how many times I've taught this class, probably 12 times. That's the mistake people make right there. And the multiple choice publishers test bank questions that I just use the publisher's question. They always put that in there. They sucker you. They bait the hook and throw it in the water. And many students bite because they're not hearing what I'm saying right now. and getting it carefully down, or they forget by test time. Of course, you've only got 2 days, so you won't forget, right? It doesn't go all the way back. People just go all the way back. Just boom, okay, just go all the way back. Then go back to 4. No. Only section C, which is right. We're never going to give people more than a marked out section for their letters. Does that make sense? C marked out 5 through 8. So that's what he gets. Good? You just keep going like that. You know, take the first number 1 marker, take the first number 2 marker, take the first number 3. We have no, but on a bigger one, which we'll do in a minute, then you just keep doing the same thing. First number 1, first number 2, first number 3, first number 4, etc., etc., etc. And then the last one, the last is the last marker on the right, and you go right, not left. All the rest, we always take the candy to the left, but in the last marker, you go right. So can y'all read that down there? Last is the last marker. Maybe I should, that's not written very neatly. Number 3, last, take, last marker on the right, and then go right from there. That's what I'm saying. That's step 3. Okay, so what am I talking about? What's the last marker on the right? Well, right here. And we go right. That means these candies. So 11, 12, 13. Who gets 11, 12, 13? What letter's left? We've given A his candy. We've given C his candy. So B is left. That's B's candy. B did put a marker there. B2 said if I had the ones to the right of that, I'm happy. All right, there you go, B. You're happy. Look at that. We have 3 leftover candies, don't we? 4, 9, and 10 are left over. And yet everybody thinks they got a fair share, don't they? According to their markers. See how the method works? Uses a little trickery to give everybody a fair share. Uses a little math, a little logic, give everybody a fair share, and there's still extra. They marked, they said what they thought was fair, we gave it to them, and there's still a couple extra. So that's the rest of the questions they'll ask you. What does A get? What does B get? What does C get? How many are extra candies, leftover candies? Leftovers 4, 9, and 10. Right? We good? That looks easier than it is. This is one of the, that's why we do the practice. Like I said, I've taught this class a dozen times. Everybody's always like, yeah, it's the easiest thing in the world. And I put that on the test, and like 70% of them will miss it. I go, I forgot about the left. You got to practice math. You got to practice math. Or you're living in a dream world. You're going to fool yourself, and the truth will come out. So, okay, look at all those markers. So give it a try. So don't worry about all the questions. It's just basically, A, B, C, and D, give them their fair share of candy. So you want to write that down on your papers there, put in all those markers. It's a lot just to write it down. You don't need to draw the pictures. Just write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then put in the markers. So D1, B1, D2, A1, C1, A2, B2, C2, D3, and 12 and 13, A3, 13 and 14, B3, C3. All right. There we go. So now do the marker thing. Let me let you do it. You get more of it if I give you a minute instead of me just doing it. So those go to D. Does that make sense? So you just take the first marker on the left and go left and give them those candies. So that goes to D. Good so far. And now you find the first number 2 marker.
So it's D.
Well, and D's out now. Yeah,
Okay, so
D's out of the game. D has been handed candy. D is done. So yeah, so what's the first number 2 marker other than D? Yeah, as soon as you've given somebody a candy, they're out. So if it helps you, you can just cross the rest of the D's out. They're done now. So what's the first number 2 marker other than the D?
A2.
The A2, yeah.
And then it goes to A1.
Good. Yes, give them their candy. Well, yeah, because we've already given D their share. D gets candy 1 and 2, so yeah, they're out of the, we've handed them their candy, they're out of the problem. Yeah, so no more D. Yeah, once you give somebody their share, they're out for the rest of the problem. So yeah, so the first number 2 marker is right here. It's the A2, right? So the D1 was the first 1 marker. The A2 is the first 2 marker, other than the D2. But how far back do we go? Only,
A1.
yeah, only between the 2 A marks.
What is it? Okay.
Does that make sense? It's only candies 7 and 8. All 3, 4, 5, and 6 are going to be leftover. We have a lot of leftovers on this one. 3, 4, 5, and 6 are all going to be leftover candies. Does that make sense how I'm coming up with that? So I took the first number 1 marker, D1, then D's out. First number 2 marker, A2. And you always go between their 2 letters, unless you're on the left side or the right side. So we're in this middle now, so we go between two A letters. You see that? We don't just go all the way left. We give A one of A's chosen sections. A put markers between candies 7 and 8. See? Right here. Between candies 7, marking out 7 and 8. So that's what they get. They thought that would be a fair share. They put their markers there. So we're giving them a fair share according to what they said. Now, grab the first 3 marker, right? We grab the first 1 marker, the first 2 marker, the first 3 marker, other than A and D, of course. A and D are out of this problem now. So if you want to mark off the A's now, that would be helpful. Do it. A and D are out of this problem now. They've been given their candy. We're not thinking about A and D anymore. A and D are out of this problem, right? No more candy for them. So now grab the first number 3 marker. What's the first number 3 marker? The B3, right? Because again, I'm not looking at that A3 or that D3. They're out. A and D are done. So it's the B3. It's right here. That's the first number 3 marker other than the A and the D, which are out. How far back does it go? Let me let you do that. How far back does that B3 marker go? Well, to the other B marker, right? Remember, you only give people a section they've marked out. You never give them more than what they marked off. So how far back for B? 10, 11, 12, 13. Because that's between 2 B marks. Right, everybody see that? That'll be what we give B. 10, 11, 12, 13. Are we good? Is that making sense? Now we've only got once you've only got 1 letter left, which we're there now. We've given candy to A, B, and D. Once you've only got 1 letter left, that's always going to be that letter on the right side. So what letter do we have left? C. Just grab C right here and go right. That's C's share. They marked it, right? It seems small, but they did it. They put a mark right there saying just that last candy, must be their favorite thing, whatever it is, 15, excuse me, is a fair share. C thinks that is a fair share. So there we go. And we're done. The rest of those, there's a lot of leftovers on this one. The rest of those are leftovers. and yet everybody gets a fair share according to how they put markers down. They could have put those markers anywhere they wanted. See how this method gives them fair share, no matter where they put their markers. Is that okay? Does that make sense? So we'll do that one tomorrow. You do it in tonight's homework, and then tomorrow we'll do it on the practice exam, and we'll talk about it. Go over it so that then on the real exam in 2 days you'll be ready to go. Any questions on that? Yeah.
I don't think it's like too complicated, but I think I can get it. But the only problem I have is I want like to start with the A.
Uh-huh.
And go to A, B, C, and D.
Oh, you wanted to go in the alphabetical?
Yeah,
right.
Myself wanting to do.
Right. I hear you. That makes sense. Yeah, it's by the numbers instead of the letters. Yeah, it's going to be the first one, the first two. Yeah, good point. Yeah, we can't go by the letters. It's the numbers. Good memory device. Yep, remember it's by those numbers. Yeah, oh, and by the way, on the practice exam, they don't put the numbers down. And so it's part of why I give you the practice exam, so you'll be ready for the real exam. No, what they'll do is they'll just give you these letters without the numbers. Like this. Well, I'm not doing a very good job of erasing them. They'll just go like this, no numbers.
So,
Like that. This is a C. This is an A. Yeah, they'll go, here's the markers on the practice exam, the one we take tomorrow, which is how it's going to be in the real exam too. They'll go, there's a D put markers here, and A, B, and C. There they are. There's the markers. Go ahead and do your thing. Well, we're really focused on the numbers. We need to see the numbers. The method I'm giving you uses the numbers like you're pointing out, right? So what should we do? Put our own numbers in there. We could do that easily enough, right?
so you just.
Let's just start with.
First D would be just D1.
Yeah.
Okay.
Just do them one at a time. Start with your first D. That's D1. The next D must be D2. The next D must be D3. Yeah, and then do B. The first B is B1. The next B is B2. The third B is B3. The first A is A1. The next A is A2. The next A is A3. The first what's left? C. C1. C2. C3. Yeah. So it's easy. Do that for yourself though. So put your own numbers in there. Just start on the left for any letter. It's A1, A2, A3, B1, B2, B3, C1, C2, C3, D1, D2, D3. Then you'll be able to use our method. Like you're saying, it's not letters, it's numbers. So you'll be able to focus in and go, okay, now the first number 1, the first number 2, the first number 3, and the last one always goes right. Is that good? All right, we'll talk more about it tomorrow after the practice exam. So hopefully that'll help. Put your own numbers in there. Okay, so Jessica, Queenie, and Sophie are dividing a set of 15 CDs. 6 country, 3 rock, 6 opera. Jessica loves country, hates rock and opera. Queenie loves rock and country. Bluell hates opera. Sophie loves rock and opera. Bluell hates country. Blah, blah, blah. CDs are lined up. Blah, blah, blah. Describe the placement of each player's markers. Use J1, J2 for Jessica, Q and Q2 for Queenie, etc. Choose the answer below. Okay, how are we? This problem probably seems very strange at first, I think. All right, here we go. Let me talk you through this one. Let's do Jessica first off. Tell me about Jessica's feelings. Let's talk about her feelings. About music, anyway. What does it say? Jessica loves country, hates rock and opera. She loves country, hates rock and opera. You hand her rock, it's garbage. Opera, garbage. Right? Loves country. So, if they are laying out the CDs in a row like that, O stands for opera, C for country, R for rock. What will Jessica, I'm just doing Jessica right now, I'll get to the other people later. Just Jessica. Put on Jessica's glasses with me for a minute. How will Jessica look at that bunch of CDs? What does she care about only? The country ones only. The rest is trash to her. So how many country ones are there? 1, 2, 3, 4, 5, 6. 6 country, right? It's all she cares about. There's 6 country. And they're going to break it into 3 sections, right? There's 3 friends doing this. So they're saying, hey, Jessica, break those CDs up into what you think are 3 equal value sections. What will Jessica do? There's 6 country, and she wants to break them into 3 equal value sections. So she'll break them each into 2 country, 2 country, 2 country, 2 country. She doesn't care about anything else, opera, rock, whatever, it's all trash to her. What she'll do is break it up into 2 country, 2 country, 2 country. You with me? Does that make sense? That's how Jessica, is that her name? Feels. 2 country, 2 country, 2 country. So where's she going to put her mark? Here's 1 country, 2, 3, 4, 5, 6. Starting on the left, she'll put her marker right there, Jessica marker 1, and right there, Jessica marker 2. How'd I come up with that? Because if she puts a marker here, how many country in the left section? 2. And how many in the middle? 2. How many in the right section? 2. To Jessica, those will be 3 equal value sections, because they each contain 2 country. Does that make sense? I came up with that? I'm just putting Jessica's glasses on, looking at how she thinks. That's what she thinks. Next, Queenie. How does Queenie feel?
Loves country and rocky.
Yeah, Queenie loves rock and country, hates opera. So Queenie now, let's think about Queenie. So to her, what is it? Rock and country. R and C are everything. All she cares about is the R's and the C's. Just count up the R's and C's and divide them by 3. Right? Make them into 3 equal sections. How many R's and C's are there up there? 1, so I'm going to count them. Are there 9?
Is it?
You might be right. R plus C and 9, is that right? C, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. 9 R's and C's. So divide that by 3. 3 each section. So Queenie will break up this whole list of CDs in a way that will allow 3 R and C, 3 rock and country. So how many? So 1, my pencil here, 1, 2, 3, right there. That'll be Queenie mark number 1. And 1, 2, 3, Queenie mark number 2. Right? Country, rock, rock. Rock, country, country. Country, country, like rock, paper, scissors. There's going to be Queenie's 2 marks. Everybody see that? That'll break it up into 3 valuable CDs in the left, the middle, and the right.
Will it always be like a even or like?
Well, this problem, they're making it that way, yeah. Real life, no.
You know on the test if it's going to be.
Yeah, real life it'll be, the test will be clean.
Okay.
Yeah, just making it nice. Does that make sense? Yeah, in real life there's a few issues you'd have to work out with when it's not even. Yeah. Good question, Cole. Yeah, that's true. And then thirdly, what else we got? Sophie. How does Sophie feel? Rock it up. You get it. Yeah, I can let you do the rest. That good? And you can figure it out, and you can allocate, and the rest makes sense, right? I'll leave it at that, and I'll go on to chapter 4 if we're good, if you're okay. That's the big bad chapter 3. States, different counties care about whether they get to put 1 or 2 or 3 representatives sitting on that board, because those people will represent their interest. Does that make sense? So this is very much real. This issue isn't just the Senate the House of Reps. It's all the time. So you have like an 8-member cabinet. There's 8 men or women that sit on a board and they decide, whether you're going to get a new dam or not. And that affects thousands of people and how their water bills work out, right? And farmers and all that, all the water they need. So people get really upset about whether they're being fairly represented on that board based on their population. And it's all about the rounding. Because we all agree on the basic idea. More people, more representatives. That's all agreed upon. It's just, what do you do when the rounding doesn't work out? Who gets the extra one? What's the fairest way to do that? That's the question. So, 60,000 customers in state A, 15,000 in B, 24,000 in C. So how should we break up the 8-member water authority? How many members on that 8-member cabinet does state A get? Well, you can see the answers. I've already done it. A should get 4.8485, B should get 1.2121, C should get 1.9394. Now, they're all going to be rounded. You can't have part of a representative. So they're all going to be rounded in a minute. How did I come up with those numbers? I took the standard divisor and I divided each of those by that on my calculator.
And how do you get the standard divisor?
That's a very good question. So yeah, let me back up and show you how I get the standard divisor so we can then divide by it. Yeah, and I'm talking and talking because I don't remember. I gotta look at my notes. What do you do? Standard divisor, total people divided by total seats. Okay, there it is. So, yeah, let me write that for you. So, standard divisor is total people divided by the number of seats. So, standard divisor, total people. So how do I get total people? You just add them up. 60,000, 15,000, and 24. So 60,000, 15,000, and 24,000 divided by 8, because 8 is the number of seats. When I did that on my calculator, well, that's actually not true. I just had the computer tell me the answer. It's 12,375. I'm going to do it right now just to make sure. Or maybe one of you guys already did it. Does that come out? I'll race you. I got a graphing calculator, so I have an advantage. Yeah, 12,375. Yep, that's correct. Good so far? You want to write that in your 3x5 card. You get a 3x5 card, right? For the practice test tomorrow and the real test on Thursday. Put that on there, for sure. Standard divisor is total people over total seats. Get that first, and then it's called a divisor, so you're going to use it to divide each of the states. So here we go then. So for A, I took the A 60,000 and divided by the 12,375. Does that make sense what I'm doing? So I took the 60,000 customers in state A divided by the divisor, and that's how you get the 4.8485. Double check. Yep. And it rounds, that 8.5 rounds because it's 848. And it rounds up. You guys remember how to round, right? The digit to the right is 5 or more, you go up. They told me to go to 4 places. So at first the answer was 4.848484, and on you go. So remember when you went around, so there's the real answer my calculator tells me. 4.8484848484 forever. And then they say round 4 places. So whenever they tell you where to round, in this case 4 places, you circle the 4th place and you look 1 digit to the right. So I circle the 4th place, which is a 4. Look 1 to the right. If the 1 to the right is 5 or more, you round up. That's why we get 8485. Is that good? So what that is, that's how many state A should get. That's a fair share. That's their part of the population. For the 8 seats. They're just a little more than half of the total population. So they should get a little more than half of the representation on the board. The 8 members on the board, they should get almost 5. Are we good? There? And then B and C are the same way, right? Just divide those. B would be, what's B? 15,000 divided by 12,375, and C is 4,000? What is it? 24,000. 24 divided by 12,375. Everybody good? questions to there? Because then we're just gonna do a little bit more. Well, that's all they want on this one, huh? That's all they want. No questions? Can I move on? All's well. Okay, if you miss it, grab the last chapter where we had a lot of variety. They're all pretty much the same. So, okay, Labor Council, done it. Electrician has 29 members, plumbers have 13 members, painters 21, carpenters. Council of 11 reps. Find their standard quota. Okay, that means do what we just did. So, council's going to have 11 reps. That's the number on the council. So we have 11 seats on the council. And those 11 men or women are supposed to represent all the rest of the people. Right? All the electricians, the plumbers, the painters, and the carpenters. So let's figure out the different things. How do we do it? What's the standard divisor first off? Standard divisor. It's the number of people. It's the total number of people. Total number of people over the number of seats. So what's the total number of people? It looks like 29, 13, 21, and 35 divided by 11 seats. So that's 8.91. That's what we got there for the standard divisor. Is that good so far? Y'all getting that? And then the quota, that's just what we did last time. So now come the standard quotas. And then so for electricians, how do you do it? What do? You just take the electrician number, which is 29 over the 8.91. Right? Is that helpful? Well, what if I write that out? You just take the number of people, the number of electricians, divided by the standard divisor. So that's 29 electricians over 8.91 standard divisor. And that comes out to be the 3.2548. How we doing? Yeah, I can answer on that, and then you just do the rest. It's okay if I just skip the plumbers, painters, and carpenters, it's the same. All the answers are up there. If you want to copy them, or you'll have your own homework question. Is that good? You can send, so you find the standard divisor, total people divided by total seats, get that, and then just divide each of the other numbers by that divisor. That's why it's called standard divisor. You divide by it. And you get what's called the standard quota. And the standard quota is what they should get. That's their true fair share. All right. So those first two were just warming up. Like, how do you get the basic facts rolling? Now, this is a real question. Now they're going to say, okay, let's actually do this thing. Let's get the quotas and use a certain method called Hamilton's, which is the easiest one, to figure out how many they're going to get. So let's go through it. So first thing you got to do on all these problems is figure out the standard divisor. All right, so what's the standard divisor? I'll let you do that. Give you a second. In fact, let me move it off to the side here. What's the standard divisor? It's the total population divided by the number of seats, right? Total population is 990. See it right there? Over number of seats. How many seats did they say? 33. There it is. 33 seats. Is that just 30? That's nice when it comes out that clean. So the standard divisor is just 30. Good. Standard divisor is just 30. And so then you just go by and divide all those numbers by 30. You guys with me? So notice I just go by now and I say, okay, standard divisor is 30. So I'm going to go 138 divided by 30, divided by 30, divided by 30, divided by 30. I just take each of those four and divide those numbers by 30. Because that's the divisor. It's the standard divisor. Pretty cookie cutter, right? Just next step, just crank it out. Okay, so I'm going to bring it down here. So when you divide, that's called the standard quota. I've already got the final answers up there. I'll show you how to get there in a minute. Let's just get the thing. So this one is 138 divided by 30. I got my calculator here. 4.6. Guys getting that? We'll get to that in a minute. That's the whole discussion, is how we're going to round. Let's just leave it there for now. Cole, you said like that's an easy part. That's the whole chapter, is how we're going to round that. 6.2. That's the part people get all upset about, is how we round it. 264 divided by 30. Right, yeah, it won't work to always just round up. Might be too many. And 402 divided by 30 is some number. And that's 13.4. Can you read that okay? My writing's a little so-so. Is that okay? Does everybody see what I'm doing there? So I just divided each of those totals by 30 and got those numbers, right? Good so far? Can I move ahead? Are we good? So you find the standard divisor, total population divided by number of seats, 30. Divide all the different A, B, C, D, the states or the people or whatever they are by that 30. Get your decimals. That's called the standard quota. That's an exact fair share. Your quota is, if somebody says, here's your quota, that's like what I'm planning to give you, right? I'm quoting you, I'm saying I'm going to give you 5.3 or whatever, right? That would be an exact fair share. Now, yeah, we can't, what do we do about the decimals? That's the whole chapter. What do we do about the decimals? Should we just round them?
No.
Like 4.6, wouldn't that round to 5? Right, it's closer to 5 than it is to 4. $4.60 is closer to $5 than it is to $4.
No, it has to equal 33. Right.
It does have to equal 33. Yeah. So maybe it'll just come out naturally good.
Doubtful.
So 4.6, right? It rounds closer to 5 than it does to 4, right? You guys with me? 6.2 rounds closer to 6 than it does to 7. $6.20 is closer to $6 than $7. 8.8 rounds closer to 9. $8.80 is closer to $9 than it is to $8. We'll round that to 8. To 9. And 13.4 is going to round to 13. It's closer to $13 than it is $14, right? And then if you add all those up, they have to total 33 because they said there was 33 seats right here. So I've written over it, but it says 33 seats, period. You can't do more seats or less seats. It's 33. If you add all those up, it does come out to be exactly 33. This time, it's not a problem. Many other times, it will be a problem. We got lucky. It turns out this is just a lucky one. It all just kind of naturally comes out fine, and there's no problem. But it doesn't always happen that way. The method they're telling me to use I really didn't even use, I just like rounded and it wasn't a problem. But it does come out to be a problem sometimes. So let me show you the exact method, the Hamilton method. The Hamilton method basically says give the highest decimals the extra seats. That's different than saying round them. Did you understand that? Give the highest decimals the extra seats. That's not the same. 0.4 might get an extra seat. Might go up in that kind of world. That's not the same as round them all. Right? That's the subtle difference you got to see in this chapter. So, what Hamilton's method says, Hamilton says do the following thing. This is actually what Hamilton did in history. Is he said, all right, let's do it this way. Let's just round everybody down at first. So Hamilton's method here, let me just write it over here. What is that? That's not what I wanted. Hamilton's method says round all down and then extra seats to highest decimals. So in other words, you round them all down at first. You just say, all right, round them down. So this will be 4, 6, 8, and 13 at first. You guys with me? We're going to get to this final answer. I'm just showing you why this is the correct final answer using Hamilton's method. You round them all down at first, and then you count them up. What's the total here? If you add those up, 21, 30, it comes out to 31 total. Everybody with me? So, how many extra seats? 30. If you're only right now giving out 31 seats, there's 2 seats left. Everybody with me on that? Because remember, there were 33 total we were supposed to give out. So this tells us 2 extra seats. We've got to give to 2 of the states an extra seat each. Well, how do you know which ones? What? Highest decimal. That's what Hamilton says. Just give it to that. I like Hamilton's method. I think it's great. We're going to get all these fancy ones in a minute. I think Hamilton's is great. Just give it to the highest ones. Done. So who's the highest one? The 0.6. Or here, I'll just make an extra column. Extra. Plus 1 here because of the 0.6 and the plus 8. I'm just looking at decimals. 0.6 and 0.8 are the highest decimals, huh? They're the most deserving of another one. So that brings them to 5. State C to 9. The 6 and the 13, they don't change. And there we are. There's our 33 seats, and we're done. And that is the answer that's listed on your handout. So it turns out coincidentally that it's the same as if we just rounded them. But it won't always be. That was just a coincidence. Really, you have to round them all down and give the extras to the highest decimals. It won't always be the same as just rounding. Make sense on that? Everybody good? Questions? Because they're going to get harder. That's the simplest one. Hamilton. Round them all down, give the extras to the highest decimals. I like Hamilton's best. It's straight ahead. I think it's good. States had all these problems with it. Anyway, let's move on. So I'm going to do all 4 methods with you guys today. I'm going to go, I just did Hamilton. Now I'm going to do Jefferson. This was going to say, do Jefferson's method. So I'm going to show you all 4 today. You will have seen them all. Tomorrow I'll do them again with you, because it'll be good to see them a second time, especially these harder ones, Jefferson, Adams, and Webster. So now we're doing Jefferson's method. Jefferson had a different plan. There were some kind of good reasons. Again, we'll talk about that tomorrow. Whatever reason, another method came along, Jefferson's method. What does Jefferson say to do? Basically, Jefferson says, let's start the same. Before we get into what Jefferson, you start the same. You got to get the standard divisor. You got to divide them all. Let's do all that. All that's the same with all the methods. So here we go. So standard divisor. Can you get the standard divisor? Give you a second. And I'll try to remind myself what Jefferson says. A new lower divisor, then round all down. Right. That's right. All right. Okay. So standard divisor, well, how do you find, it's total people over number of seats, right? Just put that in your 3x5 card. So what's the total people? 7 million over, how many seats? 140. So the standard divisor comes out, is that something nice? What is that? 50? 500? 50,000? It's 50,000, isn't it? Is that what it is? Is it 50,000?
Yeah.
Can you believe I can do that math in my head? Are you impressed? You know what that really is? I can't do the math in my head. I've taught this class so many times, I got that answer memorized. That's teaching that class too many times, huh? 50,000. 50,000. Yeah, I remember it now. 50,000. Okay. So 50,000, that's the standard divisor. So now we're going to take that and we're going to divide through all those. Right? That's what we always do, right? Same old thing there. All right, let's do that. So divide by 50,000 for this one, this one, this one, and this one. All right, so you divide them all by 50,000. So I'm going to put here, and that's called your standard quota for A, B, C, and D. So 1059, 21.18. Did you guys get that first one? 21.18. You want to save some time in your calculator, guys? Cut off the 3 zeros for both the top and the bottom, so that's fine to do, right? Right? All these numbers have 3 zeros at the back, including our standard divisor. So if you're dividing a top and a bottom of a fraction, they both have 3 zeros at the back, just skip it, right? Just cut off the 3 zeros on the top number and the standard divisor, save a little time. So I'm just going to divide the first part by 50. 57.74 and 18.04 and 43.04. We all getting that? Getting those standard quota numbers? That's the same. Nothing new so far, right? The only difference in these methods is how you give out the decimals, the rounding. That's all it is. All this whole chapter is what we do about the rounding, which seems kind of ridiculous. But that is what it's about. It's ridiculous. There was lawsuits. There was all this arguing in Congress because people are very selfish and they're very upset when their state doesn't get the extra rep. So that's what it's all about. So, all right. So we get to there. Got those numbers. So now, if this was Hamilton's method, it's not. But I just want to kind of stick in your mind the different methods. I'll remind you. If this was Hamilton's, what would I do now with those standard numbers? I would round them all down first, and then count them up, and however many extra seats there were, give them to the highest decimals. Right? You with me? Don't even write this down, but let me just do it because just remind you. I would just go, because you guys, are you guys getting the flavor? We've done this a couple times now. Get the idea? What standard quota is, that's truly fair. That's what they should truly, fairly get. But the problem is you can't get a part of a person on the count. You can't get 0.18 of a representative. Right? That would be truly fair if we could do that somehow. If 18% of their mind could be working for one state and the rest for another. You know, we can't do that though, right? So, but I just want to have in your mind the idea, because if you really get that, it'll make sense. The other methods will make sense to you. That's always better in math. If you feel the reason, then it'll be easier to remember. When you tend to make a small mistake, if you have a real reason in your mind, you'll catch it. Because you go, oh yeah, no, that doesn't fit reality. Whereas if you're just doing it monkey see, monkey do, with no understanding what's happening, you will make small mistakes and you'll never catch them. Because there's nothing real happening for you. So you want to be real. This is really a true fair share. All these numbers. That's what they should truly, fairly get, but we can't do that. We can't do decimals, so we got to round, right? So all these methods are how do we round? Fairly. What's the most fair way to round? Well, if it was Hamilton, don't write this down, because it's not Hamilton. But I think it'll be good just for me to do Hamilton one more time for you. You'd round down, even the 57.74, round down, round down, round down. That's called rounding down, everybody down, even the 0.74. I'd round them all down, add them all up. What would that be? 6, 9. That would be 139 if you add them all up. And so I would have how many extra seats? Got to get 140 total. I'd have one extra seat. Who would get it? The 0.74 is the biggest decimal. He'd get the extra seat. So he'd go to 58. The rest would stay where they're at. That'd be done. That'd be Hamilton's way of dealing with the decimals, right? And I think that's pretty darn fair. But there were states that felt differently. So we're not doing Hamilton's method. Jefferson's was done for a while. I think it was. Anyway, so what's Jefferson's method now? Jefferson, basically, some states complained, and so Jefferson came up with a method where, because states were complaining, here would be the complaint. If you did Hamilton's on this thing, and this state B ended up with 58 reps on the council, basically, state A would complain. They would say, look, I deserve 21.18. Completely fair. You rounded me down to 21, only gave me 21, and state B only deserved 57.74, and you rounded him up. In the end, he went up. You're giving him more representation than he deserves, and you're giving me less. That's not fair. So went the complaint and the lawsuits and all the rest. So that was the deal, right? So because of the complaining, Jefferson came up with a method. He said, yeah, the problem is we're rounding some people up and we're rounding some people down with Hamilton's. I don't agree with Jefferson on this, but here's how he spoke. He said, look, the problem is we're rounding some up and some down. And we need a new method where we can just round everybody up or everybody down. That way nobody feels like somebody else went up and they went down. We need a new method where we can just round everybody up or everybody down and yet have the total come out correct. How do you do that? You just divide by a different divisor than the standard divisor. Instead of dividing by 50,000, you divide by something different. What? How do you do different? You do, let me write it, make sure I got it right, a lower number and round down. So that's, I'll write this out in a minute for you. So, well, in fact, probably just write it right now. Let's go over here. Whoop, I shouldn't have risked that. So the standard divisor was 50,000. Jefferson says, here's what Jefferson says. He says, Jefferson says, find a new lower SD, standard divisor, and round all down to equal the total, the correct total. That's his plan. What are we talking about? He wants us to be able to just round them all down so that you don't have some going up, some going down. Right? What would happen if I rounded them all down right now? It wouldn't work right now. I need to go through and pick a new standard divisor. It wouldn't work. You guys know what I mean? If I rounded 21 down, it'd be 21. 57.74 down would be 57. 18.04 down would be 18. 43.04 would be 43. You add those up, you're only going to have 139 reps. It's not right. You have 140 reps. It's not coming out right. Right? Hamilton would say, well, yeah, just give the extra seat to B. Jefferson would say, that's not fair, because then B's going up and everybody else is going down. That's not fair, that's not fair, that's not fair. So instead, I want you to, and of course you guys might be looking at it going, well, yeah, that's the answer, Mr. Aaron. I'm looking at it right here. It's 58. This is the correct answer, by the way. You think it is? Just add one. It is. Well, coincidentally, Jefferson method did arrive at the same answer as Hamilton's would, but it won't always. So let me show you how you do Jefferson's method. Jefferson says, no, I don't like that round up, round down thing. Find a new number to divide by, a lower standard. So lower than 50,000. Well, how much lower? Yeah, that's the hard part. Who knows? You just kind of guess around. This is where it gets tedious on your calculator. So I'm going to try 49,000, for example. Try dividing them all by 49,000 instead of 50,000. Get the new numbers and round them all down and see if the total comes out right. If that doesn't work, try again. And just keep adjusting it. This is where it gets tedious. Just keep changing that standard divisor until it works out. When you divide them all and round them down, then it all comes out to 140, not 139, but 140, because that's the total number of reps. And that way, nobody was rounded up and some other ones rounded down. Do you get it? Let's do it now. Question, Cole?
Yeah. What if it comes out to like a bunch of decimals when you round down? Would you?
Well, we're going to round down, so we're going to cut off the decimals.
So it doesn't matter.
Yeah,
Okay.
just cut off the decimals. Yeah. Oh, but so by the way, Well, I gotta make sure you're really clear on a couple terms. We use the word round in general society fairly loosely. Let me be clear with you. There's round off, which means 0.5 goes up, 0.4 goes down. There's round up, which means all go up. And there's round down, which means all goes down. So we have to use those words kind of carefully. Right? So there's three ways. The normal way we speak of rounding, where 0.5 goes up and 0.4 goes down, that's called rounding off, technically. You know, going to the closest. And we won't always do that. In fact, technically, none of these methods round. Well, no, that's not true. Webster's will round off. But rounding up means up when they say up in math. That means even 0.1 goes up. And rounding down means down. Even 0.9 goes down. So when Jefferson says round down, he means everybody down. Just cut off the decimal, in fact, is what he means. Even if it's 0.9999, whatever, cut it. Go down. Right? That makes sense? So be careful on those terms. Round off, round up, round down. Round off is the kind you're used to doing. 0.5 up, 0.4 down. That's called rounding off. Okay, so when Jefferson says in this little steps, round down, he means it. So let's go back. And so we've got to divide. So I'm going to try dividing now by 49,000 instead of 50. How'd I come up with that? I'm just guessing. I don't even remember if that's right or not. It might not work. I honestly don't even remember. I just took 50,000 and just went down a little bit. So I'm going to, right, because 50,000 was the standard divisor. It's what I originally divided them all by, right? Jefferson says pick a new lower one. So I went, all right, how about 49,000? Now, use your calculator. I'm going to do it too. Let's go through. Let's divide what? Divide what? The original numbers by 49,000 this time instead of 50. Now, to make it easy, guys, let's cut off the 3 zeros in the back, right? So let's just take 1059 divided by 49 instead of all the zeros in the back. Because this gets tedious. You might have to do this like 4 times and keep changing it. At 49,000, we're going to have to go to 49,500 or down to 48,000, or you just keep fooling around. That's why I kind of despise these methods. But anyway, that's what we have to do. So 21 points. So I'm getting 21.6. And that's just going to round down to 21, remember? So I'm going to go down because that's what Jefferson says. I don't care about the decimals. Down with it, right? 2887 divided by 49. What am I getting? 58.9. 58. That's going to go down to 58. Next one. 902 divided by 49. 18.4. It's going to go down to 18. This is looking good, actually. So far, it's working. I can tell the numbers are going where we want them to go. I don't know if this last one will work, though. 43.9. Oh, it worked. 43.9. Look at that. I'm going to round that down to 43. Add those up, you get 140 exactly, so that's the answer. Which, coincidentally, is the same thing that Hamilton would have done, in this case anyway. But not in all cases. So it just works. Normally we don't get that lucky that it works on your first one. You sometimes have to go a little higher, a little lower, fiddle around. Hours of your life goes by, dividing numbers. Does that make sense? Not that bad. I'm being dramatic. But is that good? Does everybody see what happened there? If you get that, the other two are going to be the same thing. Because you know what Adams is? The next one's going to be Adams. Adams is going to be the same thing. It's just going to be pick a higher number and round them all up. Jefferson was pick a lower number, round them all down. And then Webster's going to go pick some other number and round it off. Those are the methods, and we're done. That's the chapter. Did you get that? So Hamilton, so the 4 methods. Hamilton says round them all down, give out the extras to the highest decimals. I like that method best. Number 2, Jefferson says, no. Pick some new number to divide by. Pick a lower number, round them down. Adams says, no, people don't like to go down, people like to go up. So pick a higher number, round them all up. It is just the opposite of Jefferson. And then Webster, I think, is actually a good one too. Webster says, no, it's better to round off. That's more true. But you might need to pick a new divisor to make that happen. So pick a new divisor so you can round everybody off. Meaning 0.5 up, 0.4 down. Those are the all 4 methods. Are we good? Can I move on to the next one? Is that good? What did I do? I took all the originals divided by 49,000, which is a lower than the standard. The standard was 50. Jefferson says, pick some lower number. So I went, okay, how about 49,000? Divided them all, round them all down, and they came out to the right total. If they didn't, they didn't come out to the right total, I would have to have tried again with a different dividing number, a different standard divisor other than 49,000. But it is going to be something lower than 50. You never go over 50. Jefferson says lower than the original. So you're not going to go over 50. It's going to be 49 or 49,500 or 48 or 48.5 or something lower than 50. Make sense? For Jefferson. All right. So here we are in Adams' method. So you know what to do. Standard divisor first off. Standard divisor 7. It's total population over number of seats. 7,500,000 over, what are the number of seats? 150, yeah, 150. Is that 50,000 again? I can't tell exactly. Or 500,000? 50,000 again? Maybe that's why I remembered them, because they just make them all 50,000. Yeah, 50,000 again, there it is again. So the standard divisor, coincidentally, well, I mean, they're making it this way, is again 50,000. Standard divisor 50,000. And now, we're supposed to, are those the exact same numbers as the last problem? Maybe that's what it is. No? Anyway, whatever. So now, we're going to do Adams' method. Let me write out Adams' method for you. Adams' method. And by the way, don't even bother. You know how last time, guys, I went through and divided them all by the standard divisor? Don't even bother with Adams' method. And really, I shouldn't have for Jefferson's either. It's only Hamilton, the first one, that you really want to get the standard divisor. For Jefferson and Adams, you don't. You want to divide by a different divisor. Adams says pick a new higher. Adams is everything goes up. Higher divisor and round all up. And remember by up, he means up. Even 0.1's going up. Everybody's going up. So it equals the correct total, right? It's all about getting the correct total in the end, right? Are these exactly the same numbers as the last one? 159. No, it's different. Different numbers. It's the same total, but the numbers are different. All right. Anyway, here we go. So I'm going to take each of these numbers and I'm going to divide by, here's the standard divisor is 50,000. That's the standard one. I'm supposed to pick a new standard divisor. This time it's higher. Right? Jefferson, it was lower. Adams, it's higher. Right? These are the 3x5 card. Put an example of each of these you want. All right, higher. So what's higher than 50,000? How about 51,000? I don't know. I'm just guessing. How about 51,000? It might not work. We might not get so lucky this time. So I'm going to divide through by 51,000. Really, I'm just going to divide by 51, right? Cut off the 3 zeros in the back, save some time. So divide each of these by, and then I'm going to round them up as soon as I got them. So here we go. So 3,280 divided by 51, 64.3. So 64.3, and then I'm going to round up. Where is 64.3 going to go when you round up? 65, right? It means up means up. Even the 0.3 goes up. Okay, next one, 2480 divided by 51, 48.6. Rounded up to 49. It's probably going to be too many. 23.9. Whoops, 23. Rounds up to 24. Yeah, this is not the right answer. We're going to have to redo this. I can see already compared to the final answer, it's not right. 10.1, rounded up to 11. If you add those up, you get 149. So close. It's supposed to be 150. No. Got to redo it, that means. Write this down, though. Keep a record. Write that down. And I'll show you how. Now's where it really gets ugly. Because you have to fiddle around. Let me show you how to fiddle around. I'm going to do it in a way that will save some time. I'm going to play warmer, colder, basically. I'm going to show you how you know which direction to go, whether to go higher or lower. So everybody got that written down? You with me? we need more seats. We're only got 149 right now, right? So we need more. We need more. If you need more, you got to divide by less. It's teeter-totter. You realize that? You ever stay up late at night thinking about, if I divide a number by a bigger number like 25, I get a smaller answer. But if I divide by a small number like 10, I get a bigger answer. Right? If you take 100 and divide by a small thing, you get a big answer. So if you want to get bigger answers, you got to divide by something smaller. Does that make sense? I'm at 149. I need more. So that means this is, how do I say it clearly? This is too low. So go lower. It sounds backwards on the standard deviation. If it's too low, go lower. Because dividing by less will give you more. Right? So if your number's coming out too low, which it is, then you need to divide by a lower than what? Lower than the 51,000. Okay, well, how about I go back down to 50? Can I just divide by 50? No, that's not a good plan. Why not? Because that's the standard. You're supposed to pick something higher than the standard. So don't go all the way down to 50. You with me? I'm going to go lower than 51, but not all the way to 50. How about 50,500? I don't know, kind of guessing. 50,500. See how that's lower than 51,000, but it's still higher than the standard, right? Adams, it's got to be higher than the standard. We're not going to go below 50 ever on this one. Okay. So now try that, and you hope it works. And I kind of have my doubts. I don't think it's going to work, and we'll have to go even lower. We might end up having to go to like 50,100. I don't know. Let's try. This is where. Oh, and I'm going to have to use all the zeros this time because I don't have 3 zeros in the back of this now. Notice. So you're going to have to use the full numbers. This is where this method gets really tedious. I already hit the wrong key. Divided by 5,500. All right, let's see. I'm getting 64.9. And you round that down to 64. And I'm getting divided by, what is it? 49.1. Round that down to 49. Oh, it's already wrong. Yeah, I'm not going to go any further. How do I know it's wrong? Because I'm looking at the final answer. See, the final answer is supposed to be 65 here. This is coming out 64. So guys, in the interest of time, this is going to come out wrong. You're going to get too low again and need to go even lower. That's what's going to happen. So let me just fix this. I'm going to go 50,100. That'll probably do it. Let's go back and try that. We need to go lower. So I'm going to do that. I don't want to. So you might need to do this several times. That's where this is terrible. So let's go back again. I just know because I'm looking at the final answer. 65.4. Yeah, so that goes down to 65. That's right. Now that might wreck some of the other ones. I don't know. I'm getting 49.5. Rounds down to 40. Oh no, are we supposed to go up? Oh, I'm supposed to go up. Hold on. Back up. That first one was right. I don't like these methods. All right. This is not why I majored in math. This is what computers are made for just all this number crunching stuff. All right, let's try again. I'm supposed to round up. I was doing the Jefferson thing. Up. You guys just tell me when I do something crazy like that. Up. Up, up, up. All right, so let's try it again. So maybe the 50,500 works. I don't know. The first one was working then, 5,500. So I'm getting 64.9. And so you're supposed to round up. Yeah, 65. So that's right then. And 2480, 123 divided by 50,500. And this is 49.1. Round up. Oh, no, I know it's wrong. 49.1 is going to go up to 50. This is going to be too high, I think. All right, let's do it. Let's just carry it through. I'll quit stopping. Carry it through. It's good. That's coming out too high. So keep going. 1, 2, 2, 1, 2, 3 divided by what is it, 50,500, round up, 24.1, round up to 25. It's gonna be close again, but wrong. I'm getting 10.3, round up to 11. If you total these, you total them, you're gonna get 151. 151, too many. Too many. So if it's too high, that's too high, right? Too high, go where? Higher. Sounds backwards, but you know what I mean. It's teeter-totter, right? If you're coming up with too high of a number, you need to divide by a higher number to bring them down. So I got to divide by something higher than 50,500, yet lower than 51,000. So it's between those two. So, do you guys want to do this one more time? Yes, we do, right? So it's got to be like, I don't know, 50,000. Who's the one that's got a 50,400 maybe, or 300? No, higher. 40. So maybe like 600 or 700. Let's go 700. 50,700 maybe, right? That's higher than 50,500 and still lower than 51. Okay, I'm going to divide by 50,700. So divide through by, so try that. 3280, 123, divided by 5,700. Are you guys just watching me do this? 64.7. So that rounds to 65. So far, so good. Next one. 2480, 123, divided by 5,700. I'm getting 48.9. Yeah, that's looking good. Rounds to 49. That's like, see, it's matching the final answers. Next one. Hope nothing else goes off. 3 divided by, what is it? 5,700. 24.06. Round up. Even that rounds up to 25. Looking good. One more. 520, 123, divided by, what is it, 50,700. I'm getting 10.2, yes, rounds up to 11, perfect, added up, 150, ding, 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 we got a winner. So there it is, I divided by 50,700. So do you see the trick there, guys? If you don't know whether to go higher or lower, you could spend half your test wasted on one question. Don't do that. Trying to divide the right numbers, right? To see how I knew whether to go higher or lower? It's counterintuitive. If it comes out too low, go lower on your divisor. If it comes out too high, go higher on your divisor. But we're always, for Adam, going to be higher than the 50,000. Right? So I ended up 50,700. Would there have been other? Yeah, 50,600 might have worked. 50,000, probably anything between 50,600 and 50,800 probably would have worked. I don't know. You know, there's not like just one number that works. There's a range of numbers. But it's kind of a pain trying to find it. All right, we got 7 minutes. We got to try the one last method and be done. Are we good with that? That awful enough for you? All right. Hamilton's the best, though, I think. But anyway, Webster basically says, hey, why don't you pick a new divisor and round them off instead of up or down? Same thing, just round off instead of up or down. All right, here we go. Standard divisor, you know, total population divided by number of seats. So it's total population, 7,500,000 divided by number of seats. What's the number of seats? 150? There's that 50,000 again, huh? That's why I remembered. It's on every problem. Okay, so standard divisor is 50,000 again, yet again. So now, Webster, Mr. Webster, who wrote the dictionary, it's the same one, the one from history, one of the founding fathers. Webster said, pick a new divisor, but this one could be higher or lower. It just kind of depends. Higher or lower, or even the same. Maybe the standard one will work. Higher or lower or same. Round all, not up, not down, off. That's the key mark of Webster. Webster said, look, we shouldn't be rounding everybody up or rounding everybody down. We should be rounding 0.5 up and 0.4 down, off. That's called rounding off. He said, that's more fair, which I tend to agree with Webster on that. Round them all off to equal the correct total. Just keep playing around, trying. You still got this difficult fiddle around thing where you try dividing by different numbers until they round off to be the right total. All right, so here we go. So for Webster, it might be the same as the standard divisor that just works. So I'm just going to try that. I'm going to divide through them all by 50,000 and see what I get. I'm just going to use 50, cut off the 3 zeros in the back, cut off the 3 zeros in the back. Here we go. 3410 divided by 50, 68.2. Round off. I'll do that in a minute. So I'm just going to go through and divide by the numbers. 2440 over 50. I'm getting 48.8. If you want to just write these down, I'll just divide them real quick. Divided by 50. I'm getting 24.4. Yeah, this is going to work. 8.6. Yeah, good. Okay, you guys with me so far? Good, we're going to finish easy then. This one will go one. This will be a one-stepper, it turns out. So what did I do? I divided Webster's. I divided them by the standard 50,000. Just hoping the standard would work. That doesn't work for Adams or Jefferson, right? You got to go down for Jefferson and up for Adams. But for Webster's, it could be just the same number that you started with. Or it could be higher, it could be lower. It just sort of varies from problem to problem. Webster could go any one of those three directions, up, down, or same. And you want to round everybody off. That's the key mark of Webster's, rounding off, not up, not down. So here we go. I'm going to round off now. Remember what off means? The way you normally round. 0.5 up, 0.4 down. So when you round off 68.2, it's going to round. Yeah, what's it closest to? What's $68.20 closest to? $68. What's $48.80 closest to? $49, right? And 24.4 is closest to 24, and 8.6 is closest to $9. Add those up, and it comes out 150 exactly. So that's your answer. So a lot of times Webster's just works with the standard divisor. If it didn't, though, if it came out too high, what would I do? If that came out 151, for example, too high, I would go higher. Remember, it's counterintuitive. I would divide by a higher number.
I thought for Webster's, all you have to do is play with the decimals.
No. Webster is not Hamilton.
Okay, gotcha.
No, Webster requires rounding off.
Okay.
So you can't go back and change your mind on the rounding. You got to do a whole new divisor. Yeah, so you got to have that philosophy. If it comes out too high, actually go higher because you're dividing by higher. If it comes out too low, go low. Right? Just keep remembering that. All right, let's end with a quick little. We're just like out of time, so I'll just give you a free clicker here. Let me get loaded in and get it up. And there it is. There it is. And open. All right, click A for Apple. You got a free 10 points on the clicker quiz. A for Apple. Got 8 responses, 9, 10. And we're done. So we finished. So what's due for homework? We finished 3.3 and 4.1. They'll be due tomorrow, so Wednesday at 12 noon. We'll take our practice exam tomorrow. We'll finish chapter 4 and take our practice exam tomorrow. Have a good afternoon, guys.
Change the dates for the homework.
Oh, yeah. I'll look on Math Excel. That's right.
I'm in on Friday because my dad